Hi followers, howdy. It's Professor Suresh. Delighted to be back once again for my 17th video in process of publication on YouTube today, 20th of May 2020. Topic once again is an emerging one. Additive manufacturing for customized product. Sky is the limit. The 3D printing process builds a three-dimensional object from a computer-aided design CAD model, usually by successively adding material layer by layer, which is why it is also called additive manufacturing. The term 3D printing covers a variety of processes in which material is joined or solidified under computer control to create a three-dimensional object with the material being added together, such as liquid molecules or powder grains being fused together, typically layer by layer. In the 1900s, 3D printing techniques were considered suitable only for the production of functional or aesthetic prototypes, and a more appropriate term for it was rapid prototyping, which is done before manufacture as part of the design process. As of 2019, the precision, repeatability, and material range have increased to the point that some 3D printing processes are considered viable as an industrial production technology, whereby the term additive manufacturing can be used synonymously with 3D printing. One of the key advantages of 3D printing is the ability to produce very complex shapes or geometries, including hollow parts or parts with internal thrust structures to reduce the weight. And a prerequisite for producing any 3D printed part is a digital 3D model or a CAD file. The most commonly used 3D printing process, 46% as of 2018, going by the statistics, is a material extrusion technique called fusion deposition modeling, FDM. While FDM technology was invented after the other two most popular technologies, stereolithography, SLA, and selective laser sintering, SLS. FDM is typically the most inexpensive of the three by a large margin, which tends to the popularity of the process. The umbrella term additive manufacturing, AM, gained popularity in the 2000s, inspired by the theme of material being added together in any of the various ways possible. In contrast, the term subtractive manufacturing appeared as a retronym for the large family of machining processes with material removal as a common theme. The term 3D printing still referred only to the polymer technologies for the majority, and the term AM, additive manufacturing, was more likely used in metalworking and end-use part production contexts than among polymer, inkjet, or stereolithography enthusiasts. By early 2010s, the terms 3D printing and additive manufacturing evolved senses in which they were alternate umbrella terms for additive technologies, one being used in popular language by customer maker communities and the media, and the other used more formally by industrial end-use part producers, machine manufacturers, and global technical standards organizations like ISO, International Organization for Standardization. Until recently, the term 3D printing has been associated with machines low in price or in capability. 3D printing and additive manufacturing reflect that the technologies share the theme of material addition or joining throughout a 3D work envelope under automated control. Peter Zielinski, the editor-in-chief of Additive Manufacturing magazine, pointed out in 2017 that the terms are still often synonymous in casual usage, but some manufacturing industry experts are trying to make a distinction whereby additive manufacturing comprises 3D printing plus other technologies or other aspects of a manufacturing process. It's all from Wikipedia. Some historical facts follow. The birth of 3D printing was in 1984 by Chuck Hull, who invented a process known as stereolithography in which layers were added by curing photopolymers with ultraviolet UV laser. Subsequently, in 1919, layer-based technology was modified with each layer being of just 0.1 mm depth, very thin. In 1999, it was used in medicine for the first time. In 2000, parts of humans such as ears, fingers were 3D printed for the first time. In 2005, 3D printing technology became open source, and in 2006, the first selective laser sintering SLS machine was available in the market. In 2008, the first self-replication printer was invented, and this printer was able to print the majority of its own components. The same year, 3D technology capability was enhanced to print very hard shapes for artists and designers. In 2019, atom by atom printing was developed to allow bio 3D printing. In 2011, a robotic aircraft besides a car were printed for the first time using 3D printing technology, but these were made available in the market only in 2012. Next year, the same year, gold and silver jewelry were printed for the first time using 3D printing technology. A 3D printer includes a set of components that operate simultaneously to produce the desired output from the input digital file. Basic components of a 3D printer are 1. Print tray, 2. Extruder, 3. Arc end, 4. Filament. There are a variety of printing technologies processed to create physical objects from digital designs. The main differences between these processes are in the way the layers were deposited to create the parts, besides the materials that are used. Some methods melt or soften the material to produce the layers, while the others cure liquid materials using different sophisticated technologies. Each method has got its own advantages and drawbacks. Here are some common technologies. Stereolithography SLA. Here, position a perforated platform just below the surface of a vat tank of liquid photocurable polymer. An ultraviolet UV laser beam then traces the first slice of an object on the surface of this liquid, causing a very thin layer of photopolymer to harden. The perforated platform is then lowered very slightly, and another slice is traced out and hardened by the laser. Another slice is then created, and then another. It's like a chain reaction until a complete object has been printed and can be removed from the vat of photopolymer, drained of the excess liquid, and cured. Second method, fusion deposition modeling FDM, where a hard thermoplastic is extruded from a temperature controlled print head to produce fairly robust objects to a high degree of accuracy. Third method, selective laser sintering SLS. This builds objects by using a laser to selectively use together successive layers of a cocktail of powdered wax, ceramic, metal, nylon, or one of a range of other materials. Fourth, multi-jet modeling MJM, where this method builds up objects from successive layers of powder with an inkjet printed used in spray on a binder solution that glues only the required granules together. Prime advantages of 3D printing are: 1. Manufacturing was made simple even for products of complex shapes. Variety is free, that is, customization is easy. No assembly is required. Zero skill manufacturing. Compact, portable manufacture, and less wastage or higher material yields. Prime disadvantages are: 1. Copyright infringement, because anybody can copy. 2. Even dangerous products can be printed like guns, knives, etc. Third, limitation on the size of the product. But this has been overcome. Nowadays, even big products like ships, houses, automotives, etc. are manufactured using 3D printing technologies. Different methods of additive fabrication can be classified by the type of material that is employed as: 1. Liquid-based process, 2. Powder-based process, 3. Solid-based process, 4. Paper-based process. Types of 3D printing technologies more exhaustive are stereolithography, SLA, fixed deposition modeling, laminated object manufacturing, selective laser sintering, direct metal laser sintering, inkjet printing, polyjet 3D printing. Metal additive manufacturing process can be broadly classified into two major groups: powder bed fusion technologies (PBF) shortly, and two directed energy deposition (DED) based technologies. Both these technologies can be further classified based on the type of energy source used. 3D printing eliminates barriers associated with the traditional manufacturing techniques. Products of any shape and configuration can be easily printed using this technology, that too quite fast. Size is no more a limitation. Personal 3D printers of today most often build things from plastic using a process called fusion filament fabrication (FFF). Plastic filament is heated and extruded from a nozzle like a tiny and precise hot glue gun. Most of you know this hot glue gun, while the machine draws out 3D objects layer by layer. As one layer of plastic is laid on top of another, they fuse together and when cooled, form a solid and durable plastic parts. This technology has been around for about 25 years and used in the design and engineering industries for everything from designing parts for cars to designing toaster ovens. Central to a 3D printer is the idea of a Cartesian robot. This is a machine that can move in three linear directions along the x, y, and z axis, also known as Cartesian coordinates. To do this, these 3D printers use small stepper motors that can move with a great precision and accuracy, usually 1.8 degrees per step, which translates to resolutions in the fractions of a millimeter range through the unique way that these stepper motors are controlled. The 3-axis robot is like any other computer numerically controlled CNC robot and is able to position its thermoplastic extruder along each of these linear axes of movement to lay down layer upon layer of hard plastic. Majority of the 3D printers available in the market use timing belts and pulleys along the X and Y axis to provide fast yet accurate positioning, and most use threaded rod or lead screws to position the Z axis with even greater precision. Extruder is required to lay down thin strands of material layer by layer to build up the required product. The print bed is a surface on which the 3D prints are built on. The print bed is then used to prevent warping or cracking of prints as they cool and to create better adhesion between the first layers of the print and the print bed surface. The surface of the print bed is often made from either glass or aluminum to better spread the heat across the area and to make for a smooth and level surface. Glass provides a smoother surface to print on, while aluminum conducts heat better for a heated platform. To prevent the object from lifting off the surface in mid-print, these surfaces are often covered in one kind of tape or another to provide a surface that is inexpensive to replace periodically. These materials include Kapton or polyamide tape, polyethylene terephthalate PET, PET, or polyester silicon tape, or even hardware store variety but blue painter's tape. Hardware store variety like the blue painter's tape, depending on the type of filament used. The type of linear motion system or the mechanical assembly that allows each axis to move that is used by the 3D printer will often determine how accurate the printer is, how fast the printer can print, and how much or how little maintenance will be needed by the printer over the long term. Most personal 3D printers use smooth precision ground rods for each axis and either plastic, bronze, or linear ball bearings to glide across each rod. Linear ball bearing systems have gained a lot of popularity lately for the longevity and smoother operation over the life of the printer. Although they are often louder during operation than bronze bushings like the self-aligning variety, which are generally quieter but often require a little more work to align during the build process. The length of travel for each linear axis is limited by usually mechanical or optical instaffs. Basically, These end stops are switches that tell the printer's controller electronics when it has reached a limit in one direction of movement in order to prevent the axis from moving past its limits. While end stops are not strictly needed for operation, having at the very least one end stop in the minimum position on each axis will allow the printer to home itself at the beginning of each print for repeatable and accurate prints every time. Holding together everything together is the 3D printer's frame. This frame forms a structural element of a 3D printer, and its material and construction determine a lot about the final accuracy of a printer. Ultimately, additive manufacturing will be the major technology for fabrication of products in space age. No limit on size or configuration or material. That's why the title is Sky is the Limit. As a matter of fact, world's leading online retailer Amazon has plans to manufacture customized products with the aid of this particular technology. You can perceive the delight of the customers when they get customized products like that. Cost of such machines and manufacturing cost will also reduce drastically once individuals and companies start using this technology on a large scale. The days of individuals with their own 3D printers at home to manufacture most of the products they need, either for self or the family members, is not far away. We'll meet again real soon. Rest in peace and harmony. As recommended, always watch these videos with closed caption subtitles for enhanced comprehension. I know pretty well that I rushed through the presentation to complete the whole thing within 20 minutes maximum. Take care. Bye.